Hello, Algebra 2 students. Today we're going to work on changing from logarithm to exponent and from exponent to logarithm. I know you kind of had the notes in the video that you had not yesterday on your catch-up day, but the other day. So this should be really, really easy and short. Okay, I want to show you this right quick, and then I'll show you what your assignment is. If you remember, we talked about exponentials and logarithms. They're inverses of each other, because if you take a logarithmic function and you switch the x and y, then you're going to get it. I don't remember which one I started with. If you start with an exponential function and you switch the x and y, you get a logarithmic function. If you go the other way and start with a logarithmic function, you switch the x and y, you get exponential. They are inverses of each other. Okay, this is an exponential graph right here. If you switch the x and y, then you'll get, this is exponential. If you switch the x and y, you get a logarithmic. This table is for exponential. If I want to make the table of the logarithmic one, the inverse of that, I just switch the x and y. So we have 0.25, negative 2, 0.5, negative 1, 1, 0, 2, 1, 4, 2, 8, 3. Switch the x and the y. Now let's plot those points. I'm going to start at the bottom. 8, 3, 4, 2, 2, 1, 1, 0, 0.5, negative 1, and 0.25, negative 2. It's a negative 2 right there. Okay. So you'll notice this is our logarithmic function that we've looked at. It's the inverse. That's my alarm telling me we got 5 minutes left in class. Okay. So that's the inverse. What did we do? We took the exponential function, switched the x and y's. Okay. All right. Let's move this up a little bit right quick. How do you write and read logarithms? So this is probably new to you. Don't do logarithms in geometry or algebra 1 or any of your previous math classes. The definition of a logarithm. Here's your exponential. This b is the base of that exponential. A base of a logarithm goes in the subscript. The exponent goes over here all by itself. So this is the base. See where it's pointing? This is the exponent. I don't want that here. I want that. That's the exponent. And then this a goes right here. It's called an argument. It really is just a number. How do you read that? How do you read this? You read that log base b of a equals x. Why do we use logarithms? To isolate the exponent. You know how when we're solving, we want to get the x by itself. So if it's added, we subtract. If it's multiplied, we divide. You always do the opposite. Well, the opposite of an exponent is a logarithm. Okay. What you're going to be doing today is rewriting using this formula. Let me erase some of this stuff. It gets kind of cluttered. You're going to use this. Remember, the base goes here, the exponent goes here, and the number or the argument goes there. So if you have 7 squared equals 49, it's going to be log base 7. That's a subscript of 49 equals 2. Or log base 2 of 20 equals x. We're isolating that exponent that's going to the other side. Okay? Log base 3 of 243 equals 5. Okay, you're just rewriting. Now let's look at the other way. From logarithm to exponent. If you're starting here, get my drawing tool back on. Two to the power of x equals 64. The whole goal of a logarithm is to isolate that exponent. Okay, base x, exponent is 2, This one, the base is 64, the exponent is 2. That's how you rewrite them. Common log uses a base of 10. So on these, you notice we don't see any base written. That's 10 squared equals 100. Or 10 to the negative third equals 10 to the power of x equals negative 3. Sorry. No. So 10 to the negative third, yes. 10 to the negative third equals x. 10 to the fourth equals 10,000. 10 to the power of x equals 1 over 10. Okay. Changing from exponent to logarithm. All right, so you're going to use this to rewrite the log. I'll do a second video where I explain a couple of examples of that to you.